What's happening, everybody? Pasting back again, and in this video I'm going to show you how to find the equation of a tangent line to a function. And in this function we have already found out previously that the derivative is f prime of x equals negative 2x minus 4. So we already have that information. We have the original function, we have the derivative. We want to find the equation of the tangent line. And previously we talked about the derivative being the limit of the difference quotient, and that is our current definition of how to find a derivative. So it was a lot of work to get this, but later on we're going to talk about how to make that much easier. And hopefully you can actually start to see the connection a little bit. So without further ado, equation of a tangent line. You need two things. You need a point of tangency. Point of tangency. They gave us an x value. So how do we find the point of tangency? We plug that x value into f of x. So f of negative 4 equals negative 4 squared minus 4 times negative 4 plus 1. So I'm going to do that out real quick. And I got 1. So I have found the point of tangency. The point of tangency is negative 4, which is our x value, our input, comma, positive 1. Well, what else do you need for an equation of a line? You need the slope of that line. So we need the slope. Whoa, what is that? And since we are looking for the slope of the tangent line, we know that we can plug in this negative 4 value into our derivative, because our derivative is going to represent the slope of the tangent line. So I'm going to plug that in and evaluate it real quick, and I'll be right back. And I found out that the slope of the tangent line is 4, and I'm going to annotate that with a slope letter, which is m, with a subscript of tan. So I have my tangent line slope. I have my point of tangency. Now I must remember point slope form. Point slope form was y minus y1 equals m parentheses x minus x sub 1. So I shall use this. I have a point and a slope, so I shall go for that. Y minus 1 equals m, which is positive 4, parentheses x minus x1, so x minus negative 4 is plus 4. After that, you can leave it like that. That is totally acceptable. You could also change it into slope-intercept form, so I'll do that real quick. And upon doing that, I have another form of my tangent line equation. So we have taken an original function, we have used the limit of a quotient, difference quotient, to find the derivative. From that we found the point of tangency, and we found the slope of the tangent line, and now we have our equations. Either one is fine. We have our equations of our tangent line. You're going to want to be a little bit more formal. You don't really want to write it like this, but for the purposes of time, I'm just kind of abbreviating. And I want to show you one more thing before I end the video. So the last thing that I wanted to show you was, keep in mind what we just found. We have this original function up here. We have just found an equation that should be tangent to that original function at the value of x of negative 4. So what I've done is I've preloaded my graph, my equations into here. I have the original function in y1, and I have the derivative in y2. And I'm going to show you the graph, and you're going to watch all the good things happen. There's the original, which is quadratic. And here comes the derivative, which is linear. And watch as it graphs. It's just going to kind of kiss the edge of that blue curve. It is going to be tangent to that curve at the exact point of x equals negative 4. Well, I hope you learned something. That's it for me. It's Friday afternoon. Y'all enjoy the weekend. If it's a weekend when you watch this, take it easy, y'all.